Good morning, dear students. This is Banani Porakasto. We are doing the chapter 3, Matrices. Today we will learn equality of matrices. So in definition 2, it is given that two matrices A, where the elements of A are denoted by small aij, and matrix B, where elements of B are denoted by small b, are said to be equal if they are of same order. They are of same order means, suppose if A is of order 2 by 2, then the matrix B should be of order 2 by 2. If matrix B is of order 3 by 3, then matrix A should be of order 3 by 3. So in this way, the two matrices should have the same order. Equality of matrices, our next condition is the point number 2. Each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and j. Now, here I and j can take what values? So let us take an example. Suppose if A and B are of order 2 by 2, then I will take the values 1 and 2. In the same way, j will take the values 1 and 2. So, in the matrix of order 2 by 2, the elements will be A11 will be equal to B11, A12 will be equal to B12, A21 will be equal to B21, A22 will be equal to B22. So in this way, the corresponding elements will be equal. Here, for the first two matrices, these two matrices are equal matrices because both are of order 2 by 2 and each element are equal. The corresponding elements are equal. So these two matrices are equal matrices. But in these two matrices, our first condition is satisfied. Our first condition was they are of the same order. So these two matrices are of order 2 by 2. But see, here it is written 3 and here it is written 2. In the same way, the next number, here it is written 2, here is written 3. So the elements of first row, first column are not equal, which is 3 and 2, and the elements of first row, second column, which is 2 and 3, are also not equal. So these two matrices are not equal. In example 4, it is given that if two matrices are equal, find the values of A, B, C, X, Y and Z. So from the given matrices, we can say that these two matrices are of same order and the order is 3 by 3. So our first condition is already satisfied. To satisfy the second condition, we have to compare the corresponding elements of the matrices. So x plus 3 corresponds to 0. So from here we can find x is equal to minus 3. From the elements z plus 4 and 6, we can find the value of z, which is 2. From the elements 2y minus 7 and 3y minus 2, we can find y is equal to minus 5. Now look at the elements minus 6, minus 21 and 0. These are already equal, so we need not do anything with these numbers, and these are the corresponding elements. So let us move to a minus 1 and minus 3. From here, by equating a minus 1 and minus 3, we can find a is equal to minus 2. Next, 0 and 2c plus 2. By equating these two, we can find c is equal to minus 1. b minus 3 and 2b plus 4. By equating these two, we can find b is equal to minus 7. So, in this way, we can find the values of a, b, c, x, y and z. In example 5, the question is find the values of a, b, c and d from the following equation. So, in the equation, two matrices are given, and these two matrices are of same order. They are of order 2 by 2. So here we have to find out the values of A, B, C and D. So since these two matrices are of order 2 by 2, so our first condition is already satisfied. To satisfy our second condition, we have to compare the corresponding elements. So we have to equate the corresponding elements. So by equating the corresponding elements, we can find the values of A, B, C and D. So let us move to exercise 3.1, where up to question number 5 we have discussed. Now question number 6. Find the values of x, y and z from the following equations. So in question number 6, 3 questions are given. So in each question of question number 6, each matrices of order 2 by 2, 2 by 2. This matrix is of what order? This matrix is of order 3 by 1. Here we have 3 rows and only 1 column. So in question number 6, for all the questions, the first condition is already satisfied. We have to just compare the corresponding elements of each question to find the values of x, y and z. In question number 7, find the value of a, b, c and d from the equation. Here also the same type of question. Here also the order is 2 by 2 for each matrices. Here we have to compare the corresponding elements. That means we have to equate the corresponding elements, where a minus b will be equal to minus 1, 2a plus c will be equal to 5, 2a minus b will be equal to 0, 3c plus d will be equal to 13. So in this way we can find the values of a, b, c and d. These two questions we can do as we have done in example 4 and example 5. Our next question of exercise 3.1 is question number 8, and the question is a matrix A is equal to, where the elements are denoted by small a, aij, and this matrix is of order m by n, is a square matrix if. So what is the condition for a square matrix? condition is the number of rows should be equal to number of columns. So the value of m should be equal to the value of n. So our answer will be m is equal to n. Whenever m is equal to n, then the matrix is a square matrix. Now in question number 9 we have which of the given values of x and y make the following pair of matrices equal. And for this question we have 4 options, option A, B, C and D. So in the given question we have 2 matrices and both of these of order 2 by 2. So our first condition is already satisfied. So to find the values of x and y, let us assume that these 2 matrices are equal. So by equating the first element 3x plus 7 is equal to 0, from here we can find that x is equal to minus 7 by 3. From the next one 5 is equal to y minus 2. From here we can get y is equal to 7. From the next one y plus 1 is equal to 8, and from here we can get y is equal to 7. From the next one 2 minus 3x is equal to 4. From here we get x equal to minus 2 by 3. So here we get the values of x are minus 7 by 3 and minus 2 by 3, and which is not possible because x can have only one value. So our answer will be option B. It is not possible to find the value of x and y so that these 2 matrices can be equal. So in question number 10, the question is the number of all possible matrices of order 3 by 3 with each entry 0 or 1 is 4 options are given. We have to find the number of matrices which are of order 3 by 3. And each element will be either 0 or 1. So if it is a 3 by 3 matrix, so we have 9 places to fill with 2 options, and these 2 options are 0 or 1. To fill each place we have 2 options. So for the first place we have 2 options, for the second place we have 2 options, for the third place we have 2 options. In this way, for all the 9 places we have 2 options to fill the places. So our answer is 2 to the power 9, which is 512. So our answer is 512. This process you have done in class 11 in the chapter permutation and combination. If you find it difficult to understand, then you can tell me. So with this we have completed our exercise 3.1. In my next video I will start operations on matrices. You keep on practicing exercise 3.1. So till then, bye.